Hello friends, this video on electrostatic potential part 10 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 9 before going ahead with part 10. Let us look at potential at a point due to an electric dipole. You remember in the last chapter we talked about the electric field due to an electric dipole. We talked about the electric field at an axial point, at an equatorial point, right? So the same things we will discuss here, but here we will calculate the potential. So what was our observation when we talked about the electric field due to electric dipole? We found that electric field varies directly, it varies with x cube. Right? However, in general, electric field varies with 1 by x square. That is, it is inversely proportional with x and it varies with x square. But in case of electric dipole, it varied with x cube. That was a speciality which we observed in our previous lesson. So here let us try to calculate the potential due to an electric dipole at an axial point. So let us suppose this is an electric dipole. Axial point means a point which lies along the axis of the dipole. You are now familiar with all these terms, axial, equatorial, because I have explained all this in the previous chapter, right? So let us suppose this is an axial point and we have to calculate the potential at this point. So let us mark this axial point as point P. So this is my dipole. So let us call this is plus Q, this is minus Q. Let us mark this point as A, this point as B, and the distance between the dipole, which we normally took as 2A before also. Now, what is the distance of this point? In case of dipole, we always measure the distance from the midpoint of the dipole. So let us say that this axial point lies at a distance of x from the dipole. So we have to calculate the value of electric potential at this point P. So we will have electric potential because of both the charges. So first let us calculate the potential at P due to A. Then we will calculate the potential at P due to B. So what would be the potential at P due to A? That will be equal to K into Q. What is Q? Q is plus Q divided by the distance of point P from A. So what is the total distance? This is x and this distance is A, right? So this will be A plus x. Now similarly, what will be the potential at point P due to B? That will be KQ divided by, but here it would be minus Q, divided by this distance. So what is this distance? It is nothing but x minus A. From x you subtract this much distance. So this would be x minus A. So what would be the net potential? I told you before also, net potential is always sum of the potential. It doesn't matter which because potential has no direction, right? So earlier it was whether you have to add or you have to subtract or you have to find the components when you talk about electric field, because it has direction also involved with itself. But in this case there is no direction, so whatever contribution you have from each of the charges, just add them up. So this becomes KQ divided by A plus X minus KQ divided by X minus A. So this becomes minus KQ into 1 by A plus X minus 1 by X minus A. So this becomes equal to, this becomes x square minus A square. This is x minus A plus X. So let us do the remaining calculation this side. So this becomes equal to KQ into x minus A minus X divided by x square minus A square. So x will cancel. So we have minus 2A K into Q divided by x square minus a square. Now what is this 2a into q? Charge multiplied by the distance between them is defined as dipole moment. So 2a into q is the dipole moment. Therefore net potential becomes equal to minus kp divided by x square minus a square. So this is the net potential at an axial point due to an electric dipole. Now if your x is very greater than a, then what happens? That means if this axial point lies at a very far off distance when compared to the distance of the dipole. So in that case, V net becomes equal to minus kp divided by x square. Right? So this is how we calculate the value of electrostatic potential due to an electric dipole at an axial point. So, thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.